Assalamualaikum and hi everyone. Alright, so we meet again. Today we are going to discuss about sp3 hybrid orbital. So we take a look at the definition. Alright, we can define the sp3 hybrid orbital is mixing s orbital with 3 p orbital. So it will form 4 sp3 hybrid orbital and it will form 4 electron pair. And all the 4 electron pairs are arranged according to tetrahedral shape with a bond angle of 109.5. So we can take a look at the diagram here. So one s orbital, okay, mixed with 3 p orbital, and it will form 4 sp3 hybrid orbital. We take a look at the example. So I have two examples here. Okay, so the first example is CHCl3. So first of all, you have to draw the Lewis structure. So here is the Lewis structure. Next, draw the molecular shape. Okay, but first we have to identify the class of compound. Right, so we have 1, 2, 3, 4 bonding pair electron. So the class of compound here is AB4 and the shape here is tetrahedral. Okay, so you can draw the molecular shape like this. The bond angle here is 109.5. So this is the sample of the explanation. Okay, molecular shape of CHCl3 is tetrahedral with the bond angle of 109.5. Okay, next, to determine the type of hybridization, so we can refer back to the molecular shape. We have 1, 2, 3, 4 sigma bonds. So there are 4 electron pairs. So the type of hybridization is sp3, and the 4 electron here is arranged according to tetrahedral shape. Alright, next we move to the orbital diagram. Alright, so first you have to draw the orbital diagram for the center. That is refer to the carbon, okay, at the ground state. So we know that carbon have 4 valence electrons. Okay, at the ground state, carbon have 1 paired electron and 2 single electron, which means at the ground state, carbon can only form 2 sigma bond. Okay, so you can write like this. Mixing 1 2s orbital with 3 2p orbitals form 4 sp3 hybrid orbital. And at the hybrid orbital, we can see there are 4 single unpaired electrons. Okay, at the ground state, okay, for the hydrogen, consists only 1 valence electron that is located in 1s. Whereas for the chlorine, okay, so chlorine, so it has 7 valence electrons. So from here, we can look that, so for the sigma bond, there are 4 sigma bond here. We go back to the molecular shape. Alright, so the first sigma bond is involved overlapping, okay, one s orbital of hydrogen with one sp3 hybrid orbital of carbon. While the other 3 sigma bond is referring to the overlapping of 3p orbital of chlorine with the other 3 sp3 hybrid orbital of carbon. First sigma bond and the other 3 sigma bond. Alright, so you can write the explanation like this. Okay, overlapping 1s orbital of H with sp3 hybrid orbital of carbon form sigma bond. Overlapping 3p orbital of chlorine with sp3 hybrid orbital of carbon form sigma bond. Okay, now we want to draw the orbital overlap. So we start with drawing the sp3 hybrid orbital. That is tetrahedral shape. So for the first sigma bond is involved overlapping of 1s orbital of hydrogen with sp3 hybrid orbital of carbon. So therefore you have to draw spherical shape. And the other 3, okay, sigma bond is involved the overlapping of 3p orbital of chlorine with sp3 hybrid orbital of carbon. Don't forget to label sigma bond. Okay, next you have to label the orbital 1s. This is 3p. Okay, one more is the hybrid sp3 hybrid. Okay, and finally, don't forget for the atom, this is hydrogen, Cl, and the center here is carbon. So we have done for CHCl3. Right, so we proceed with the second example, PH3. Yeah? Right, so first of all, of course, you have to draw the Lewis structure. So right here, I already draw the Lewis structure. Don't forget to count the total number of valence electrons. Next, we have to draw the molecular shape. So we have to identify the molecular shape. So there are 3 bonding pair electron with 1 non-pair electron. So the class of compound is AB3E. Alright, so the shape here is trigonal pyramidal. So here is the molecular shape. The bond angle here is less than 109.5. So we refer back to the molecular shape. So there is 1 sigma bond. Okay, 1 sigma bond, 2 sigma bond, 3 sigma bond, and 1 lone pair. So when we total up, there are 4 electron pair at the center atom. So because of that, the type of hybridization is sp3, and the all 4 electron pair are arranged according to the tetrahedral shape. Okay, don't get confused here. Okay, 4 electron pair for the sp3 hydroorbital are arranged according to tetrahedral shape. But the actual shape for the molecule is trigonal pyramidal. Okay, now we move to the orbital diagram. Alright, so first you have to write the orbital diagram for the center. That's referred to the phosphorus. So phosphorus, we have 5 valence electron. So meaning that phosphorus would have one paired electron and 3 single electron, which is satisfied with the molecular shape. Because we want to form 3 sigma bond with 1 lone pair. So meaning that, so there are 3 single electron, okay, that can form 3 sigma bond here. And the paired electron here is represent the lone pair electron. At the ground state, you can write like this. So at the ground state, okay, phosphorus can form 3 sigma bond. Okay. So meaning that no electron have to be promoted. Since at the ground state, it is satisfied to form 3 sigma bond and 1 lone pair. Okay, now we have to mix together 2s orbital with 3 2p orbital to form 4 sp3 hydroorbital. So here is the explanation. So at the hybrid state, so we have 1 paired electron with 3 single electron. Okay, now write down the orbital diagram for the hydrogen. So hydrogen only have 1 valence electron that is located in 1s. So from here we notice that the overlapping to form the sigma bond is between the 1s orbital of hydrogen with sp3 hybrid orbital of phosphorus. So you can write the explanation like this. So overlapping of 1s orbital of H with sp3 hybrid orbital of P forms sigma bond. Okay, and then of course since there is 1 hybrid orbital accommodate the lone pair, so we have to explain about that. So this is the example of the explanation. One of the sp3 hybrid orbital of P accommodates 1 non-pair electron. Okay, that is for the explanation. Now we move to the orbital overlap. Alright. So the shape for sp3 hybrid orbital is tetrahedral. So we start drawing the shape of sp3 that is tetrahedral. Alright, so the sigma bond is involved overlapping of 1s orbital with sp3 hybrid of phosphorus. So the shape here is spherical shape, draw the spherical. And then don't forget to draw electron and also label sigma. One sp3 hybrid orbital. This one you have to draw 2 electron to show the lone pair. And the last part is you have to label. So this is hydrogen. And this is phosphorus. Oh, don't forget inside of the hybrid orbital and also the s orbital, you have to label. So this is sp3. Okay, we have done.